And yes, of course, our FNC Data Grid is also available for C++ developers. Maybe this was a little bit under highlighted. That's why we created this video, especially for you C++ developers, to have a look at the FNC Data Grid from the C++ perspective. We'll start with the basics. What targets in C++ are supported by our FNC Data Grid? And then the first steps to access cells in our data grid, how you can use methods where the t-value type is used, and we'll build everything together in a first demo, everything built with C++. So this time, let's go in the Red Studio IDE with the C++ personality, and let's discover the possibilities of the FNC Data Grid with C++. And we are in the Red Studio 12 IDE with the C++ personality enabled, and our first C++ project here in the project manager. And as you can see, the default target platform is Win64-bit Modern. This is now default in C++. That's why our demo will use this target type, but know that there also is the possibility to use the Win32 target or Win64-bit Classic target in connection with our FNC Data Grid. But let's focus on Win64-bit Modern. Let's get started by dropping a data grid on the form. Here is the default grid, how it looks like at design time. And the first steps I would like to take with you is to have a look at how we can access cells in our grid. We can do that in different ways, and a first possible way is by using the strings array accessor, so we can access cells as strings with an array indexing, of course. A second method is to use integers to set the cell values, and that is done with the array accessor ints. And we can do like in a very similar way the same for floating point values, for example like this, to set floats with the floats array accessor. Know that by default the grid cells are t-value based, so you can use different types of values to access the cells with, and when you use the t-value based access, then you will of course use the t-value type, and here we will use the strings or string type to set as a cell as a string, but via using t-value. So this is the first step to show you how you can access the grid cell values. Let's compile and run this example to see how this works. And as expected, you can see in this column access as strings, access as an integer value, and access as a float value. So that is quite simple to get started with the grid. In a second step, I will now initialize the grid with some pre-built code. You can see here that I set the column count to 7, the row count to 100. I also enable filtering and sorting in this grid, and I'm using the built-in method load sample data, which generates some random data and fills the grid with it. I show you also here how you can control the formatting in a column. So here we are accessing the fourth column in the grid, and we are specifying the number format for this column. And here I'm showing you how you can use the colors array accessor to also change colors in cells. Here we are using an FNC color value, but it is equally possible to use VCL color types in a more direct way, this way, to set colors for cells. So with this initialization done, let's see how this results at runtime. And here you have our grid. You can see that the colors are set as expected. We have here our number column that is formatted this way. You can see the format specifier and the result in the grid. And you can also see that filtering and sorting have been enabled by these settings here. Options filtering enabled, options sorting enabled, both to through. In a next step, I want to show you how you can now programmatically also perform the filtering and sorting. And to do that, I will add two buttons on this form. First button will be the one from where I will perform the filtering, and the second one will be the one from where I will do the sorting. I also prepared a code snippet to accelerate this video, and so this is the code snippet that will perform programmatic filtering. So what's happening here is, first of all, I'm clearing any possible previous filters that were added to the grid, and then I'm adding two new filter conditions. Filter.add is the method to use for that, and the first specifier is the column on which I will want this filter to be applied, and I'm selecting the column by its header name with this method column index by header. This is the filter condition, that the value in this column starts with here what is specified here, LA. And note that this method accepts also a t-value. That's why I need to specify this parameter in the method as a t-value. The same applies to the second filter conditions for the status column, with the equal condition that this value in this column should be office. And when the filter is set, I can call apply filter, and that is all to perform programmatic filtering. I will also immediately call the code for sorting and paste it here in our second button click event handler. Here I'm picking the column with header number 1, and I specify to perform ascending sorting. That's sufficient to perform programmatic filtering and sorting. So let's have a look when these things are operational at runtime. I click on filter. You can see filtering performed on this name column and on this status column. When I trigger sorting now, you can see that sorting was performed numeric on this column number 1. And I want to conclude this first C++ demo with two other interesting options, and that are the export capabilities in the FNC Data Grid. We have export methods to various file formats, and I want to show you in this demo how you can do that for HTML and how you can do that for PDF, really with a minimum amount of code. For PDF, we will use a non-visual helper component, that is the TMS FNC Data Grid PDF IO component. As you can see, as I dropped it on the form, it automatically already initialized the data grid property to the data grid that this helper component should export. There is an interesting option that I want to enable, open in PDF reader. So with that property set, the PDF file will automatically open in the default reader when it is generated. To effectively generate these HTML and PDF files, I need to perform the HTML generation. Save to HTML data is the method that I can use. Output.html I will use as a file name. And to perform the export to PDF, I use the PDF IO component with its save method and specify the file name output .pdf, and that should be sufficient to generate these files from our application. Let's run the app and see it at runtime. I click on the HTML button and you can see in our browser the generated HTML file. And when I click now on PDF, you can see that the default PDF reader was opened on this generated PDF file that contains the content of our data grid. And with that, I hope you are as excited as we are about the vast array of possibilities that open up with the FNC Data Grid when using it from your C++ applications. Know that also all the other examples in videos that we have shown that have focused on the Delphi side, everything functionality-wise that we have covered there is also available for your C++ applications. As a hint to help you to reuse from code from these Delphi examples, ChatGPT or any other AI can surely help you to convert the Delphi code in the C++ code for your C++ applications. But for this specific example, we wanted to create a 100% C++ demo, which you can also download. Find the download link below this video. And don't forget, if you are interested in more content around the FNC Data Grid or other components that can help you to be more productive, faster, more efficient, with more possibilities for your applications, subscribe on this video channel and you will be notified when we have more content for you. For now, thanks for your interest, and I wish you fun, exciting times exploring the FNC Data Grid from C++.